Hi, I'm Gary Rubenstein, and this is the 18th part of a series of videos I've been making, starting with school math in kindergarten and working my way up through the years, and I've gotten to what might be the final video number 18, trigonometry. Well, there could be more videos after, because there's more topics, but I'm trying to get what are the essential topics, and just want to use this one to talk about trigonometry. When you hear the word trigonometry, it makes people very nervous. People remember, oh, trigonometry, that's when I got lost in math. Or if you hear from somebody saying, oh, I'm taking trigonometry, it sounds very impressive. And it sounds scary and difficult. And in this video, I want to tell you, what is trigonometry? What even is it? So let's take a look. Trigonometry has to do with triangles at its most basic understanding. It has to do with triangles. And we've seen in other videos that sometimes if you know some information about a triangle's got 3 sides and 3 angles. It's got 6 things. And sometimes if you know some of those things, you can figure out others of those things. Like this first one over here. In a previous video, I showed you that if it happens to be a right triangle, the long side is the square of the long side is the sum of the squares of the 2 short sides. Whoops. 25. That's Pythagorean theorem, so we can figure out missing side. In this second triangle, we have 2 70-degree angles. When that happens, you use something called an isosceles triangle. So whatever the length of one side is across from one of the 70 degrees will be the length of the other one. And here I have a triangle. I don't know any of the sides, but 2 of the angles add up to 150. And we want all 3 angles to add up to 150. So the missing angle is 30. That's not quite trigonometry yet, but those are examples where we know some stuff about triangles, and we could use some math to figure out some other stuff. Now here's 2 other questions. And these are questions that we haven't seen yet. In the first one, both of these things have right triangles in them, and that's relevant. And in this one, I know this side is 3, and I know this angle is 53, but I don't know this side here. And there's not an easy way to do this, although I'm going to show you how trigonometry will enable us to do this with a little help from something called the trig tables. And here's the second question. I have a right triangle with 5 and 2 as 2 of the sides. And the question is, how big is this angle here? Those are 2 questions that we can do with trigonometry. And anytime you're doing trigonometry, unlike with algebra and just regular geometry, with trigonometry, we need a reference table known as the trig table. I'm going to bring one up for you. Well, when you look at this thing, it can be pretty scary looking, because we have 267 of these cryptic numbers. And these numbers are part of a reference table, because you can't do trigonometry without either a table like this or a calculator that gives you the same information and more. So what are all these numbers? Understanding what these numbers are is something that a lot of people don't know so well. So I'm going to show you. I'm going to zoom in for a minute on, first of all, there's 4 columns in this table. There's angle, then it says sine, cosine, tangent. And the angles go from 1 to 89 degrees. So that's why there's 267 of these cryptic numbers in this table. Let's sort of zoom in on one of them. Okay, let's look carefully at the row for 53 degrees. So it says 53 degrees, sine is about 0.8 approximately. And it says cosine is approximately 0.6. I'm going to round these. And the tangent, it's around 1.33. What does it all mean? Well, one way to think of it is that somebody figured out that if you had a right triangle with a 53-degree angle, and if the hypotenuse was 1, they figured out that in that little triangle, the length of the legs would be this 0.7986. The side across from the 53 degrees would be this number here. And the side adjacent would be that, 0.6018. So don't worry about this for now. That's what someone figured out. And it's not easy to figure that out. It's not like they draw a picture and measure it with a really precise ruler. But let's just say they figured this out, that for this right triangle with a hypotenuse of 1 and an angle of 53 degrees, the other two sides are these two numbers. So how is that useful? Well, it's useful if I'm being asked to solve a question like this, a question about a different right triangle, bigger one, but it's got a 53-degree angle in it. So this triangle, sorry I didn't draw these looking similar enough, but these two triangles are similar triangles, like one's just a bigger version of the other. So in this bigger triangle, I'm told that the side across from the 53-degree angle happens to be 4. So I'm told that. And I'm asked, how big is this side? So without trigonometry, I'm pretty much stuck on this question. I can't solve it. But with trigonometry, I can say, okay, on this reference table, it says that when the angle is 53 degrees and the hypotenuse is 1, the side across is 0.7986, and the side adjacent to the 53 is 0.6018. So using that, I can set up similar triangles and say 4 and x, 4 is the medium length side of this triangle, and x is the small side. That's going to equal 0.7986 in this partner smaller triangle over 0.6018. And then I can cross multiply 0.7986x equals 4 times 0.6018. And eventually I'll end up with x equals 3. So I was able to solve, or approximately, I was able to solve for x. But it wasn't using algebra. I had to use this fact, these facts about the 53, 90, this is 47 degrees. They have to add up to 180. I have to know this fact Without this fact, I cannot proceed. And that fact comes from the so-called Trig Chart. So with this Trig Chart, I can answer any question of this type. I'm going to call this, I'm going to use the rounded values as I do the next page here. So we have for 53 degrees, sine is about 0.8, cosine is about 0.6, and tangent is about 1.33. I'll say more, I want to say more about this. I just want to stick with this for now. So imagine I have a question again with a 53-degree angle. And this is 20, and I don't know how big this side is. Well, my reference table tells me that if the hypotenuse was 1, this side opposite would be about 0.8. Because that's what this number, the 0.8, means. You can put the 0.6 here now if you want also. You might wonder, what about the 1.33? I'll tell you about that in a minute. But for now, another way to think of this is that, of course, the hypotenuse is the longest side of a right triangle, and the side opposite is a leg, and it's shorter. But how much shorter? Well, apparently, for a 53-degree angle, this side is going to be about, it's like 80% as big as the hypotenuse. So this number could be thought of as like what percent of the hypotenuse is the opposite side. So for this question here on the left, I could say x is 80% of 20, which is 16. Or if you prefer the similar triangles, you can say, x is in the same triangle as the 20, x is the medium side, 20 is the long side, and this little tiny triangle, 0.8, is the medium side, and 1 is the hypotenuse, and you cross multiply and get the same answer. So we say this number tells us the relationship between the opposite side and the hypotenuse in a 53, 90, 47 degree right triangle. And every 53, 90, 47 degree triangle has this relationship. The opposite side is always about 80% as big as the hypotenuse. So one way to think of this number, besides being like the length of this side of the smaller triangle, is it tells us what's called like the ratio between the opposite side, the side opposite the 53-degree angle, and the hypotenuse. That's where some people say SOH for sine. Sine equals opposite over hypotenuse, if you ever remember learning that mnemonic device. Okay, let me say a little bit more about these numbers. So if I have a question like this, again, we're only looking at the line with the 53. There's 89 lines like this, so we can do this for any angle between 1 and 89, but I'm just sticking with the 53 for now. Let's say this is 30, and we don't know how big that is. So using our trig table, we could, this isn't how most people think about it, but I hope it's a good way to give an introduction to this topic. So this 0.6 is the length of this adjacent side in the little baby version of this triangle. Now, this also says that they figured out that when you have a 53, 90, 47 degree triangle, that the side adjacent to the 53, of course it's less than the hypotenuse, but how much less? Apparently, it's 60% as big as it, because 0.6 is 60% of 1. So I could, in this question on the left, I could say, well, if this side is 60% as big as the 1, then the x is going to be 60% as big as the 30. You get 18, which is the answer there. So what people say is that in any, the 0.6 could be thought of as like what percent of the hypotenuse is the opposite, is the adjacent side, sorry. And with that, we say like cosine is equal to adjacent over hypotenuse, meaning if I take the 18 divided by the 30, I'm going to end up with a 0.6 because it's 60% as big. Of course, this side was 24 because the opposite side is 80% as big as the hypotenuse. And we say that sine is opposite over hypotenuse. Tells us that the 0.8 is what I would get if I divided the opposite side, opposite to the 53, divided by the hypotenuse. It's 80% as big, so opposite over hypotenuse would be about 0.8. And now I can use, even without this third one, I haven't talked about tangent yet, but even without it, you can answer pretty much any question where you have the 53-degree angle and the right angle, and if they tell you any side and ask you about any other side, you could use these numbers. Actually, you could just use these two numbers, because you could create this little baby triangle, and then you could use similar triangles to figure out the missing side. So you might wonder, well, why do I need this third number, and what does it represent? Well, that third number is the relationship between, if I ignore this hypotenuse right now, is the relationship between the opposite and the adjacent. So in a 53-degree angle, if there's a 53-degree angle here, this one's 47 degrees. So this adjacent side to the 53 is going to be a little bit less than the opposite side. But how much less? Well, the 1.33 tells us that the opposite compared to the adjacent, it's about 33% larger. Or said another way, if you multiply 18 times 1.33, you'll end up with 24. And you might remember, if you've taken trigonometry before, in America at least, we memorize the 9-letter word SOHCAHTOA, which there's various stories for remembering them. But it tells you that sine is the relationship between the opposite and the hypotenuse. Cosine is the relationship between the adjacent side and the hypotenuse. And tangent is the relationship between the opposite and the adjacent. So here is a 53, 47, 90 right triangle with sides 18, 24, and 30. And if you divided 24 over 30, you would get 0.8. And if you divided 18 divided by 30, you would get 0.6. And if you divided 24 divided by 18, you get 1.33. Now, what people usually do when they're doing a so-called trig question is they don't draw in this little tiny triangle. The standard thing that people do, I'll make up a new question now. So again, I'll stick with 53, but of course this could be done with any angle. I would just have 3 different numbers coming from the trig chart. So let's just say this is 14, and I don't know what this is. So usually what you do is you look at what you've got. Okay, what was given to me? Well, the 14, which happens to be the opposite side of the 53. And what's the unknown? The x. And the x happens to be the hypotenuse, because it just is the longest side. So then you look which of the three things relates the opposite and the hypotenuse, and the answer is the O and H are there with sine. So you say, well, sine 53 is always going to be the opposite divided by the hypotenuse. Then you go to our table and say, well, sine 53 is 0.8. So the opposite's about 80% as big as the hypotenuse. It's going to be bigger than 14, the hypotenuse is. You set up this equation, and then you cross multiply. And 14 divided by 0.8 gets something bigger than 14, gets 17.5. So with this, there are basically 6 different questions you could answer. Here they are. They are all using a 53, 90, 47 triangle, and depending on which sides are known and which sides are unknown, in these two, sine would be used because it's the opposite and the hypotenuse that are involved. In these two, you would use cosine because the cosine, the adjacent and the hypotenuse are involved. And in these two, you would use tangent because it's the opposite and adjacent that are involved. But at its heart, these 3 numbers are telling us that in the 53, 47, 90 triangle, the opposite is 80% as big as the hypotenuse. The adjacent is 60% as big as the hypotenuse. And the opposite is basically 133% of the adjacent. It's bigger. And if you look back at the trig chart, you can see we could do this for any triangle. And just to drive the point home, imagine I had this situation. 35, 10, x. So for this one, the known side is the opposite, and the unknown side is the adjacent. So according to this thing, we would use tangent. And the relationship would be tan of 35 equals opposite over adjacent. Then we would go over to our chart, and we would be able to look up, or if you have a calculator, you just type in tan 35 and it tells you 0.7. So 0.7 is 10 over x. That's telling us that the opposite is 70% as big as the adjacent in this 35, 55, 90 triangle. 0.7x equals 10, x equals 10 over 0.7. So we expect it to be a little bit bigger than 10, and it does. It becomes about 14.3. Now, another thing that you can do with the trig table is imagine I have a triangle. And I know this is 5 and this is 2. And I want to know what's this angle here. Well, we can actually find the unknown angle using the trig chart also. So we know in this triangle that 5 and 2 are the opposite and the adjacent sides. And we can also see that in this case, the opposite side is 2.5 times as big as the adjacent side. So the way we say that is tan, you don't mind if I call this an x, tan of this angle is the relationship between the opposite and the adjacent, which in this case is 5 over 2, which is 2.5. So we want to find out, is there an angle whose tangent is 2.5, meaning an angle so that if it was in this triangle, the relationship between the opposite and the adjacent, or the opposite would be 2.5 times as big as the adjacent. When does that happen? Well, if I come over to my trig table, this one, I look here in the tangent column until I find something that's close to 2.5. And I see right here (2.47) at 68 degrees. On a graphing calculator, I say tan inverse of 2.5. It'll give me an even more accurate 68.2 degrees. But basically from this chart, I'm able to work out that x is 68 degrees. Because on the trig chart, this number, I looked for what angle is it the fact that the opposite is 2.5 times as big as the adjacent. And if you look at our most famous right triangle of all, the 3, 4, 5 right triangle, if I put an x here, I can choose which two sides we're going to use. I'm just going to use the 4 and the 3. Actually, I'm not going to use the 4 and the 3 because that's what I did in the last example. Instead, I'm going to use the 4 and the 5. So we don't actually even need this 3 here, but we know that's what it would equal. So for this one, if I know the opposite is 4 and the hypotenuse is 5, I would say, for what angle is it true that the opposite over the adjacent, which is 0.8, for what angle is it true that the opposite is 80% as big as the hypotenuse? In other words, when is sine x equal to 0.8? Well, we have that over here. We search through the sine column and look for 0.8, or as close as we can get to it, and we get 53 degrees. So in a 3, 4, 5 right triangle, we can say x is 53 degrees. So trigonometry is, it's a little scary. You got these 87 values, but those values are values that people figured out so that, and wrote them down in a reference table, said for every, so for any angle, we have the relationships, how the sides are related to each other for every angle. Now you might say, well, that's been 28 minutes, but isn't trigonometry like a year-long thing? Well, yes. There's more we do with trigonometry. Like sometimes we have a situation where our triangle is not a right triangle. We have two sides, or we have one side, something like that, and there's not a right triangle in there. So there's like clever things you do, like you split it up into two right triangles and kind of work with it. I don't want to get into the details of that, except that there's other configurations besides right triangles, but we can take any triangle that's not a right triangle and kind of split it into right triangles, or if it's an obtuse triangle, well, we could always split it this way. But sometimes instead we go like that and we make it, and so there's like a right triangle, like a right triangle here, make it red, and then it's overlapping with a green right triangle. I guess what I'm getting at is that triangles are the basic building blocks of everything, and right triangles are the basic building blocks of non-right triangles. Now, there's more to trigonometry than just solving for missing sides of triangles in different configurations. But I don't want to talk about those right now. Maybe there'll be like an epilogue videos. But I think at least the idea of what trigonometry is, if it scares you, or if you're overly impressed when someone says, "Oh, my kid's taking trigonometry." Ooh, well, trigonometry is mainly applying the values from this chart that someone figured out. Now, part of trigonometry sometimes is, how do they calculate out these values? That's its own story. I have made actually videos about more difficult topics, getting into like the nitty gritty of some of this math. If you check out other videos on my YouTube channel, I have hundreds of them. But I accomplished my goal, which was to make a series of videos that begins with kindergarten math and ends with trigonometry. And it took 18 parts. So if you watch this all, you've watched over 9 hours of me talking about math, which is basically, if you're ever at like a party with me, that's what I like to do, pull someone aside and talk to them as long as I can about math. And what happens is that after like 10 or 15 minutes, that person like says, "Oh, I need to go refill my drink." Then they never come back. So I have to find another person, start over. I never got to 9 hours before. So, and many of you might have pushed pause and went to get a drink, maybe never came back. But maybe someone made it through all these videos. If you did, be sure to click like or something, share it with your friends. I'll probably make more videos another time, but for now, 18 parts, kindergarten through trigonometry. Some of these videos, I just kind of said, "Oh, I want to do one on this," and I just kind of pushed play and started going. Some I thought about for like a week or 2 weeks, just in my mind. And like this one, I actually made a full video and didn't like it. So I had posted that and I took it down and replaced it with this one. I wasn't trying to make these totally polished, of course. It was just meant to be like my musings on these various topics, and I hope you got something out of them. So, farewell, and I hope I didn't bore you too much. Bye.